All right, we're now moving on to section 8.4, and this is just going to be one video long. And this is going to be still using our right triangles, our SOHCAHTOA that we learned. We're still going to be using that, but now we're going to be using it to solve for different types of problems in which we're going to deal with elevation angles and depression angles. All right, and one of the things that you need to be able to understand for this video is that you can use the angles of elevation and depression as the acute angles of a right triangle. And what's key is these angles of elevation or depression are formed by a horizontal distance and a vertical height. And we'll go over exactly what this is, but because we have a horizontal distance and then a vertical height, we create these right triangles that allow for us to have these, that we can use our trigonometry, right? So it allows for us to solve for problems using the horizontal distance and a vertical height. Right, so here's a picture of a girl or a woman standing outside looking up at a hang glider. Now, if she were to be looking straight, her eyesight would be this sight here. That is her horizontal eyesight, as if she's standing looking straight. The hang glider, if he is looking straight, his eyesight will be going here. So that is his horizontal line. Now, if these are two horizontal lines, we know that their two eyesights then are going to be parallel because they're both horizontal lines. Right? Now, if the hang glider is looking down at the woman and she's looking up at him, this is their line of sight. So her line of sight is above her natural horizontal line. So this is an angle of elevation because she's looking up. Here's the natural eyesight of the hang glider, as if he was looking straight, and now he's looking down at her, so it is an angle of depression. Right? So an angle of depression means that you are looking down, whereas an angle of elevation means you are looking up. And because these two lines are parallel, the angle of elevation, or the horizontal line of both the person and the hang glider, these two angles are congruent because they are alternate interior angles. So the angle of elevation of the woman looking up is the same as the angle of depression as the hang glider looking down. All right. And if you look over here, this gives a detail in words as well of exactly of what I just said. So the angle of elevation is the person looking up. The angle of the angle of depression is the person looking down, and they are congruent to each other because they are alternate interior angles. All right. So now let's use this to solve for a couple of questions. The first type of questions that we're going to solve is just using it to be able to identify whether or not it's an elevation or depression. So here we have a bird, and here we have someone in a hot air balloon. All right, and then the question states, what is a description of the angle as it relates to the situation shown? So what type of angle is angle 1? Well, here's the horizontal line, the eyesight of the bird as if it was looking straight. Here's the bird looking down at the person in the hot air balloon. So angle 1, since they're looking down, is an angle of depression from the bird. Angle 2, I'm going to do next. Here's the eyesight of the human in the hot air balloon looking out. Well, here the person is looking up to the bird. So angle 2 is an angle of elevation of the person. So it's an angle of elevation of the person. Now, because these two lines are parallel, we know that angle 1 and angle 2 are congruent because they are alternate interior angles. So I know, I'm going to highlight them both in yellow, I know angle 1 and angle 2 are congruent. All right, next we will continue with the person's eyesight from the person. So this angle 3 is the person then looking down at the base of the mountain. So that would be an angle of depression of the person. And this angle 4, the last one, would be as if the mountain had an eyesight, which obviously it doesn't, but this angle is formed from going up from the base of the mountain to the person. So this is an angle of elevation from the base of the mountain. And once again, these two angles are also parallel, so that means that, these two lines are parallel, so that means that these two angles are congruent. So because they are alternate interior angles, so then I'm going to highlight those in green, so that way we know that angle 3 and angle 4 are congruent. Right? So you must be able to identify whether something is an angle of elevation or an angle of depression. And also you must be able to fill in where these angles are based on the problems. All right, so now we're going to do two examples of actually solving for this. All right, the first example is, suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground? So here's the person standing looking out. They're looking up at an angle of 56.5 degrees. All right, so since his horizontal line of eyesight and a vertical height, they will represent 90 degrees. So this means that we can use our SOHCAHTOA to solve. So we want to solve for then what's opposite of the eyesight. Let me write that in red so we can see that a little bit better. We want to solve for what's opposite of the person standing, and this is our adjacent, and this will be our hypotenuse. So the one that we would use, because we don't really care about the hypotenuse, since we're not trying to solve for it and they don't give us anything about it, that means we won't use our cosine and we won't use our sine. So the one that we will use is tangent. And tangent of 56.5 is equal to our opposite, which is x, the unknown, over top of our adjacent, 53. We will then plug in tangent of 56.5 into our calculator, and it will be 1.51 is then equal to x over 53. We will then multiply 53 to each side. And remember, when we do this, you must plug this as answer into your calculator. And then from here, we will have that x is approximately equal to 80.1 feet. So that means this here is 80.1. But they want to know what the distance is of the entire turbine. They want to know what the distance is, the height of this entire turbine. So it's not just 80.1, because we know that your eyesight is 5.5 feet above the ground. So that means this portion is 5.5. So to get this final answer, you would have to do 80.1 plus 5.5, and that will give you approximately 85.6 feet. So that means the turbine is approximately 85.6 feet. All right, now one of the things I forgot to say in the other video is remember to make sure that your calculator is in degrees mode. And if you're not sure how to do that, please message me on Remind, and I will walk you through how to make sure that your calculator is in degrees mode. If it's in radians or gradients, then you're going to get the wrong answer, because this tangent of 56.5 will give you a different number other than 1.51. All right, now there's one more question for this, and then we're done for this section, and we're done for this video. All right, so this question is: to approach runway 17 at Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from a height of 2,714 feet above sea level. The airport itself is 1,007 feet above sea level. So that means the distance from this airplane to the airport itself is 1,707 feet, because we would have to do 2,714 minus 1,007, right? Because that would tell us this height here. Now, to the nearest tenth of a mile, how far from the runway is the airplane at the start of this approach? All right, so one of the things you need to make sure that you understand what they're asking for is when they say how far away is it from the airplane from the runway, they mean the actual distance. So they mean the distance of this line here. So that's what we're trying to solve for. So we're going to try and solve for the hypotenuse of this triangle. All right, if they wanted to solve for this distance here, then they might phrase the question as how far away from the plane is the airport on ground level, or something like that. There'll be different types of questions, and we'll go through the way that they will be worded. All right, so now we have this triangle where we know this is 1,017, and we're trying to solve for x here. Now the problem is this 3 degrees, this angle of descent, is not actually in our triangle. So you can solve for this one of two ways. Since we know that these, let me highlight it in red, since we know that these two lines are parallel, we know that this angle and this angle have to be congruent. So we can then fill in 3 degrees here if we wanted to, or since this is a vertical height and a horizontal line of distance, we know that that's 90 degrees, so we know it's a right angle, which then means this whole thing is 90 degrees as well. So we can do 90 minus 3, and we can identify that this angle is 87 degrees. It really doesn't matter which way you do it. I'm going to go ahead and I'm going to use this angle, though, just to use sine. It really doesn't matter. You can highlight this angle and use cosine. It really does not matter. So I'm going to highlight this angle here, and I'm going to say sine of angle 3, because this will be our opposite, and this will be our hypotenuse, is equal to 1,707 over x. All right, so now I will multiply each side by x, and I will plug sine of 3 in my calculator, so that will give me 0.0523x is equal to 1,707. I will then divide each side by 0.0523, and that will give me that x is approximately equal to 32,616.20 feet. And they asked us to round it to the nearest tenth, so it would just be x is approximately 32,616.2 feet away. So that means the airplane still needs to travel another 32,600 plus feet to get to the airport. All right, so that is then applying angle, depression, elevation. I know this video was a little bit longer than I'd like, but this is the only video of the section.